So welcome to your first introduction video to rates of reaction. In this video we will cover the 4 factors that can affect rate of reaction, and we'll also look at collision theory, which is the underpinning principle of what is needed for a reaction to take place. So collision theory is all about colliding particles, the fact that in order for a reaction to happen, the chemicals must actually bump into one another. And for a chemical reaction to take place, there's actually 3 things or 3 conditions that must be in place. The first is that the particles must collide with one another. However, not every time 2 chemicals collide with one another will that result in a reaction. In fact, the majority of the times, the 2 chemicals will actually just bump off each other without a reaction happening. One thing that can help that collision turn into a reaction is if the particles have enough energy. So in order for a reaction to happen, the particles must have a minimum amount or a minimum quantity of energy, and we call that the activation energy. But again, even with the activation energy, it's not guaranteed that a collision will result in a reaction. We also need the particles to collide with the correct geometry. So for example, whenever 2 molecules react, it's going to be one part of one molecule reacts with one part of another molecule. And so if the bits that are going to react with one another are not the bits that are colliding into one another, nothing can happen because they're not in the right orientation or geometry relative to one another. So we need the geometry, we need the energy, and we need the collision in order for a reaction to take place between 2 chemicals. And if we want to make collisions happen more quickly and a reaction to be more likely or a reaction to go more quickly or faster, we need to affect collisions. So we can speed up a reaction by increasing the frequency of collisions or increasing the energy that the particles have so that more particles have the activation energy. So we're going to look at the 4 different factors that can affect rate. So we're going to look at particle size or surface area, concentration, which is how much of a chemical is dissolved in a solution, pressure, which deals with gases, and temperature. So particle size really only affects solids that are reacting with gases or with liquids. When we break apart a solid, we decrease its particle size, and that results in more of the surface of that solid being exposed to other chemicals. So when you decrease particle size, you increase the surface area. Now, reactions occur on the surface of solids, so the more surface you have exposed, more collisions can happen between the solid and the other chemical it's reacting with. So by decreasing particle size, we can increase the frequency of collisions, and this increases the rate of reaction. Similarly, if you increased the particle size, you would decrease the rate of reaction. Concentration. So we've got 2 images. We've got one on the left-hand side representing low concentration and one on the right-hand side representing high concentration. Now, concentration is the property that only solutions have. So when a chemical is dissolved in water or another type of solvent. Low concentration means that we have not many particles in the same volume. High concentration means that we have more particles in the same volume. Now what this means is that particles are much closer together the higher the concentration, and the closer things are to one another, the more frequently they are likely to bump into one another. You can imagine this as in school when you're using the corridors. When there's hardly any people in the corridor, you hardly ever bump into someone, but whenever the corridors are filled with people, you're likely to bump into someone quite regularly. And the more frequently you collide, you're going to increase the rate of reaction because of the more collisions. Pressure is exactly the same principle as concentration, except for pressure, it's a thing that only affects gases rather than anything else. So low pressure is represented by the picture on the left and high pressure represented by the picture on the right. If we increase the pressure of a gas, we do exactly the same as increasing the concentration of a solution. We make there be more particles in the same volume. Particles are going to end up closer together, so they will collide more frequently. And this results in increasing the rate of reaction. The final factor we're going to look at is temperature. And temperature is perhaps the most important factor when it comes to affecting the rate of reaction, and you'll find out why. So when temperature increases, that temperature is a representation of energy. And so if you increase the temperature, you give the particles more energy. And this has two effects whenever it comes to the rate of reaction. The first is that when particles have more energy, they move faster. And if they're moving faster, they're more likely to bump into one another. Using my analogy of walking in the school corridor, imagine instead of walking down the corridors, you had to run at all times down the corridors. If you're running, you know that you would bump into a lot more people than if you're moving slower. The second thing that increasing the amount of energy that the particles have does is that it actually means that more particles are likely to have that required minimum amount of energy, the activation energy. So more collisions are actually going to be successful at being reactions. And so when you increase temperature, you really increase the rate of reaction quite significantly, more so than any of the other factors. So to summarize, I've listed the 4 factors, and then I've said whether or not it affects the frequency of collisions or whether or not it affects the energy that the particles have. And you can see that particle size, concentration, and pressure all affect the frequency of collisions, but have no effect on the energy, whereas temperature alone affects the frequency of collisions and also gives the particles more energy, which is why temperature is the most important factor at controlling the rate of reaction.